This question is titled, what do I do if I need overlapping groups or to group by multiple things at once? And we're going to talk about window functions, and we're going to talk about why we might want to define a window frame. And where we're starting to get in the sticky mess of SQL, we're starting to get very deep into this, is you've seen all of the different things that you can do in a select statement. You can group by, you can self-join, you can have a subquery, you can have a temporary table. You've seen all these mechanisms. So why on earth do we need yet another one? What does the window function give us that we don't already have? And as we start to reach our limit of features that we can absorb, the most valuable thing that we can do is take one giant step back and go back to thinking how SQL wants us to approach these problems. SQL says a table is a collection of tuples, a space of tuples. Each one of these rows of text here corresponds to a tuple, and each one of these tuples happens to have a number of elements to it. They each happen to have 3 elements. And any sort of query problem that I want to do is always going to be some input tuple space generating some output tuple space. And there's going to be rules on how each step along the way, each feature that I can apply is going to allow me to perform a transformation from this input to this output, especially since there's really limited ability to do things like use variables in the sense that we want to use them, have control flow in the sense that we want to have very dynamic control flow. And so what we might think is when we do a select from, that specifies what our input tuples are. And it also specifies what our output looks like. Our output of a select from will always have exactly the same number of rows as our input. So if we know how many rows the output should have, and our input doesn't have those number of rows, we got to do something there. One thing we could do is add a where clause. A where clause specifies the filtering of the inputs, and it specifies that filtering on a per tuple basis, which means we can filter these tuples that have elements A and B, columns A and B, on a criteria of A less than B. That's fine. But we cannot filter these on a criteria of this element here is less than the max of all of these elements. The where clause can only look at one tuple at a time. It can look at multiple fields of the tuple, but it can only look at one tuple at a time. If we have a where clause, we're specifying the number of output tuples that we have, which will just be equal to however many input tuples minus however many got filtered out by a criteria. If we do a group by, what a group by does is it specifies the grouping of input tuples by formatting them into non-overlapping partitions. And it determines what a grouping is on a per tuple basis. So what we do is we take each individual tuple and we extract a key from that, and that key is used to find the similarities, to find the groups. A group by fundamentally specifies the size of the output. A group by is going to have as many output rows as you have distinct groups, which means if you don't want one output row for each distinct group, a group by is not the solution to your problem. Unless what you want is one group or one row per group minus a couple of those groups. On a group by group basis, you eliminate things. That's what the halving clause is. It's really just taking the computation that you perform on the group and just nixing some of these groups by considering on a group by group basis, do I keep this group or not? What the select join, the self join or the select from with 2 columns is it's changing what your input data set looks like. It's changing what your input tuples are by saying, oh, first, take all of my input tuples and create the Cartesian product. And allow me at the same time to perform a filtering of that, but instead of filtering these on a single tuple by single tuple basis, by virtue of having constructed the Cartesian product, now I can do filters that look at multiple tuples at the same time because I've basically synthetically kind of created a new tuple that joins these together. In other words, here you can think, oh, that's kind of interesting. If I computed the Cartesian product here, then I'd get, let's do like a 0, 0. No, that's right. And then here, that would be this value, and I got to get this value as well. I'd have 9, and you get the general idea here. This just kind of goes here, and this goes here, and then here I go to the 1, 1. And once I construct this Cartesian product, then I can eliminate any one of these possibilities, I can start filtering. But instead of filtering on one row at a time, I can filter on a tuple constructed from 2 rows at a time. This is why that self-join gives you that single-step capability. You're basically filtering on 2 rows, the parent-child relationship and the child-grandchild relationship. When we think about pandas, and we think about group bys and pandas, we think about a couple of different things. We think about taking something that looks like this, unique categories with a name and a value, and figuring out what is the sum per category. So we get a 3, 7, and 5. Okay, all of the rows with category X gave me the A and B row with the 1 and the 2. All the categories Y gave me the C and D row with the 3 and the 4. All the ones with Z gave me the E row. Okay, 3, 7, and 5, that's fine. And we can think that the pandas group by basically gives me the ability to take groups and to perform aggregations. For each group, get one resulting row. But with the pandas group by, I can also do transforms. And here what you can see is I took all of the input rows of my data and I performed an operation on the groups, grouping by X, and the result has the same number of rows of the import. This is the rule of the transform. However many rows you start with is however many rows you end up with. And so here, it grouped up the A and the B, and it gave me the 1 and the 2. It grouped up the C and the D, and it gave me the 3 and the 4. It grouped up the Z and the E, and it gave me the 5. And if I put in that name column as well, you would see that, this is this row corresponding to this row up here. This is this row corresponding to this row up here, and so forth and so on. What it appears to be the case is that the SQL group by forces your output to have a certain shape. The SQL group by is actually like a group by ag. And we know that we definitely want to have the pandas group by with the transform because we've seen this before. We've seen a pandas group by with like an expanding transform, like a cumulative sum. For each group, compute the cumulative sum of everything you see. So here for this group, the A and the B, for just the A, give me a 1. For the A and the B together, give me a 3. For the C by itself, reset the starting point, so I get a 3. For the C and the D row, add these together and get a 7. For the Z row, give me a 5. I kind of want that. That's something that's useful. But I can't do that with the group by in SQL. Instead, in order to do this, I need a window function. And when we think about what the window function gives us, it gives us the ability to do windowed operations on potentially overlapping windows, and also to do window operations on multiple windows at the same time, and also to do windowed operations where the output is not collapsed to one entity per partition, one row per partition. In other words, if I perform a sum, this is like the pandas sum. I can group by each category, I can do a sum. Fine. By virtue of doing the group by, I have forced myself to have one row per unique category. There's no way around that. With the window function, however, I can look at each name, each category, and each value, and I can do this sum over our partitioning. But this partitioning doesn't force my output to have one row per category, because you can see my output retains the same shape as my input. This is very similar to my pandas group by with a transform and a sum. Similarly, if instead of partitioning, I partition and I order this, I get my cumulative sum. Here, I have the same number of rows as my input, and I have some running value, and that running value is getting reset every time I change my groups. Fundamentally, the group by coerces the output to have a certain size, one element per group, and the window function allows you to do groups, but instead of coercing the output, it allows you to preserve the output one element per original source element, one row in the output for each row in the input. What the window function also allows you to do are things which are kind of tricky to do with the group by. For example, with the group by, you can do a max over 2 columns. Here, this data has a column X and a column Y. And you can give me the max over the column X and the max over the column Y. That's fine, 3 and 10. But you can only group by one thing at a time. You can't group by 2 things in the group by because the group by specifies what the output looks like. So you can't say, oh, do this grouping here and compute this thing, and then do this grouping here and compute this thing. It doesn't work. Similarly, if we were to try and compute this data, and we were to try and say, give me all the rows where X is at the max for this, we end up getting something here. This is kind of strange, right? Like we're trying to see each name, each category. We're not grouping it. We're trying to find each x value. So the x value is the maximum overall. So, oh, okay, I see what we're doing. That's pretty straightforward. What we're trying to do is we're trying to find all the rows where we're at that max value. Easy as can be. We don't even need a group by for it. Whereas, if we wanted to do something where we looked at the min or the max, we might write it like this with the group. Easy as can be as well. We can compute a min or a max over that fixed grouping. Here we do need the group by, but we're able to compute two things over that group. However, if it were the case that we wanted to compute things over distinct groups, for example, if our data didn't have a category, but it had a category and a facet, and these were distinct categorizations of the data, where the category does not imply the facet and the facet doesn't imply the category, there's two different parallel categorizations for these, then the group by will not help us. Because the group by is going to say, I'm going to give you one entry per category if you group by category, or one entry per facet if you group by facet. But there's three categories and two facets. You have to decide, do you want three rows in the result or 2 rows in the result? What you want to do then is use a window function. Because the window function can say, oh, give me each original source row and compute a value using this categorization, using this partitioning. Give me a partitioning by the category. Or take the original data and compute a value given this partitioning. Or take the original data and compute a value with both partitionings at the same time. This is not possible to do with the group by at all because a group by is going to force you to have one row per however many unique facets or categories you have. But here, what you actually want is to preserve the shape of the original data and to say A has this value, and this is the maximum value for this for whatever facet A is in. This is the maximum value for whatever category A is in. Or what you might want to do is you might want to rank these. You might want to say, well, A has this value, and it's the number one value in its facet and the number one value in its category, and there's 3 elements in the facet and 2 elements in the category, and so forth and so on. And if we want to, we can also look at the category and the facet for these. Just to round this out, so here, let's take out the counts, just so we don't scroll off the size of our screen. But here we can see, okay, this is the value for A, and this is the rank it is in category X. This is the rank it is, or the rank it is in facet 0, and the rank it is in category X. We could not do this with the group by, but we can do this with the window function. So anytime we think that the output should have exactly the same number of rows as the input, however, we need to perform some sort of grouping operation, that's where the window function comes in. Or if we say we need to perform some operation, and that operation needs to do multiple parallel groupings without forcing the output in a certain shape, that's where the window function comes in. If we go back to our problem of, we have some sort of timestamps here, and we have some values corresponding to those timestamps, and we want to figure out how we are going to find some sort of rolling mean of these timestamps, you might think, well, that kind of sounds like the window function. Here, I can take my values and I can group them by the date time values I have, and I can see the count of values. So if I do this order by date time, you can see for the first computation, I'd have 1 element. For the next computation, I have 2 elements, and so forth and so on. So it's just kind of stacking these up. If I change my frame, I can do a window function with a fixed frame size. I can order by the date time, and I can look at rows between the current row and 2 rows before. So this is going to take this one row. This is going to take this row and the one before, and this is going to take all 3 rows. It kind of looks like a pandas rolling with a min periods equals 1. If I try to do this in order to solve my problem of what's the rolling mean every 15 minutes, it kind of looks like this works, because I could compute something on, for 9:15, I could compute something on 9:15, 9:05, and 9:10. For 9:30, I can compute something on 9:30, 9:15, and 9:05, like the average, and so forth and so on. But notice, the window function presumes a fixed window size. An important qualification on the window function is we can make this window function operate on a programmatic window, like a window that's set by an expression. Rows between 1 plus 1 preceding and the current row. But we cannot make this window function operate on some variable size. The the frame clause cannot have a variable number of rows, and as a consequence, the window function can only perform windowed looks at data where the resulting computation must have a fixed number of rows. And because one of the premises of our rolling operation here was that sometimes we have 3 signals, sometimes we have 2 signals, sometimes we have 1 signal, sometimes maybe we don't have any signals. We cannot do this with our window function. If we think about the window function, it's not just a different way to think about the group by, it is fundamentally a different type of step in our process. When we break down each piece of our logic, we can think the group by is about taking partitions of rows and generating one output for each one of those partitions. Whereas the window function is about taking the original input data and partitioning it in one or multiple different ways and supplementing the output with an additional computation. And so the shape of this change is quite distinct. In other words, a group by on A, B, C, and D with these groupings, these X's here and these Y's here, let's put an E here. A group by would say collapse everything with a similar group into one row and allow me to perform a computation on the group as a whole. So I can perform a computation on something with D and E. I can perform some computation on A, B, and C. Whereas the window function says, if I have A, B, C, D, and E, and I have this grouping, then I want the output to look like A, B, C, D, and E. But supplementary in this, I want to have some function on A, B, and C, some function on A, B, and C here and here, some function on D and E here, and some function on here and here, on D and E here. And that would be just the regular window function. The window function, this is partition over. If I do this with the partition over and the order by, then what I have is some ordered window, some ordered set. So here this just gives me a function on A, this just gives me a function on B and C, and this gives me a function on A, B, and C. This gives me a function just on D, and this gives me a function on D and E. And if I have multiple window functions, well, what that means is I might have multiple categorizations, multiple distinct categorizations, and I want to perform 2 operations on those categorizations separately. Here, if they were both order by, then I would be performing some computation on A. I'd be performing some computation on A and B. Here, I'd be performing some computation on just C by itself, because I'm looking at a different value for this rightmost column. Here, this would be a computation on A, B, and D, and this would be a computation on C and E. This is what the window function allows you to do. The group by does not give you the capability of doing this because you can think group by can't. The group by has already specified what the output looks like subject to the grouping. This is where you should start to begin to see how these different operations are not just, oh, group it in this way, give this result. They really are fundamentally different way of thinking about the problem, and it all comes down to transformations of these tuple spaces and computations and filterings that you can perform.